So, hello everybody. Oh, yes. Um, like Shimori said, I will be kind of giving you an introduction to visualization, which is also a class that I teach usually in the fall, which is a combined undergraduate and graduate class. So, if this whets your appetite, uh, then you can think about joining that. Now, I actually kind of wanted to start with an activity because this is, I hope that everybody is familiar with Sage. So all of the stuff is going to be on the Sage board, and you can grab the slides as well if you're interested. The board is this Go Hawaii EDU MTM. Um, and I'm a part of the Sage development team, so that's why everything that I do on Sage. And our activity is going to be, we're going to look at some charts now before we talk about visualization. And you guys are going to maybe add some notes or annotations about how to improve them. And this is gonna be the area where we look at the slides, at the different graphs. And I want you guys to kind of just look at each of them for a few minutes and think, are they good? Should they be improved? How would you improve them? Yeah. So just feel free to add little notes next to. I could do a note next to um, one of these with your notes, or you can suggest something with some annotations, which is yeah. Yeah. Am I able to drop the link? I should be able to easily drop the link. Where do I The only problem is that I never remember where the chat is when I am. Oh, there you go. When I'm in full screen share. There, this is. Yeah. So I see there's a guest. Um, I'm not sure that as guest you'll be able to add things to the board, but you'll be able to at least look at stuff and download it or whatever. But hopefully, I think some of you are aware that Sage was a pre-requirement to this workshop, I think.
You went Hawaii or Hawaii development?
Hawaii.
Okay.
Sometimes if you click on that link, I should show you guys again. This link, sometimes you have to click more than once to get into the board. So I don't know why. Here as well. So if you don't have the Sage, you can look at these over here, but I don't know if you'll see the details. Just really think about what you're looking at. You kind of almost all of them. Right. Okay, did you guys kind of gather your thoughts? Yeah, not really. No idea. Do you have a feeling like this doesn't make sense, but I don't know why? Is that something that you feel maybe? No?
Yeah, it's like for me, it's like look great. So I don't know where to improve.
So there's a few questions here. Are the labels properly, is everything properly labeled? Is the color scheme clear? Does it represent the data accurately? Is it the kind of chart that is appropriate for the data? Or is there any kind of elements that confuse the viewers? So let's kind of very, very quickly look at some of them. Um, let's look at this one. Oh, wait. So this is trying to show top messaging apps by country. But look at the colors that this is using, right? So uh, some of these are maybe more distinguishable. You can tell the difference between this dark blue and this green, but some of these colors are incredibly similar because you can see that these apps use a very similar kind of color scheme, which makes sense from a marketing point of view for them, I guess. But when we try to make a chart, it makes it very, very difficult to tell the difference between three slightly different shades of green, right? Um, this one is one of my favorite. What do you think would be the number one thing to change in this chart? Hmm?
Colors to the words.
Yeah, so kind of intuitively, when you look at it, you see, oh, the tallest bar is green. Surely the most favorite color for shoes is green. But then you actually read the labels, and that is not the case. So there's a disconnect between the things that you're reading in the labels and the things that you're looking at the actual chart. At the very least, if these were all in the same color, you would know that you need to read the labels. But the fact that they're all in different colors kind of makes you assume that you're looking at the thing that they're describing. Uh, this one. Do any of you manage to read this? I can't. I mean, maybe some people can, but the fact that the area is filled and the colors kind of don't distinguish themselves, make it really hard to read the actual details of this chart. So, what are we achieving with this chart, right? Um, this is kind of memed a little while ago because it's so bad. Uh, I think you guys can probably assume that the Indian ladies are not tiny in comparison to their friends, the giant Latvians, right? So what is the thing that causes this to look so weird? It doesn't start at zero, right? So we have like a very, very small difference of 5 inches between the smallest piece of data and the highest piece of data. And it kind of just starts at 5, which makes the whole thing look skewed. And the fact that they're using the icon and the icon, grows by area rather than by height is not helping this. Sharks, I think, yeah. So what's the problem with this one? It's very cute, right? You want to like it. The skill is extremely not uniform. So look at what happens between 6 and 500. And then it jumped from 4,500 to almost double it without any representative doubling of the length, right? So it's very charming. It's just not good at representing the data that it's kind of showing, right? What else do we have here? Oh, we already talked about this. This one. Whew. What's up with this one?
The three-dimensional map is hard to read.
Yes. So the older folks will perhaps remember when the Office suite offered three-dimensional visualizations as part of their basic chart. So they were prevalent everywhere. You had three-dimensional pie charts, three-dimensional bar charts, and so forth. But depending on the angle that you put your three-dimensional chart, you can skew the perceived length of things. You see these things that are very kind of close together. It's hard to see is the red taller than the yellow or the yellow taller than the red, because it depends on the perspective that we're getting the 3D in. So instead of just reading the data, which we could if this was just a 2D bar chart that had clumps of these 4 things, right? We find ourselves unable to properly read this information. So, in this, so what would be like the first thing that you would perhaps do trying to fix this diagram? This is about when Europeans fly the nest. Organize with? So one thing you can do is you can organize by color. So you have the different countries that have the different ages, right? So under this, you could have Finland, Sweden, Denmark, Estonia, and so forth, right? That's one way of doing it. What's another way of doing it? The circle are very hard to read, right? Here's another thought. This is an actual place, right? Do we care about the locations of these countries? Then maybe we could actually show this on a map, right? This kind of gumbo visualization is really not giving us much, right? So now that I showed you guys a bunch of less than great visualizations, you might want to ask, well, so why are we trying to learn about visualizations, right? It's clearly very easy to make them badly. So here is one of the first arguments that you will ever see for visualizations. This is called the N-scope quartet. It is a set of 4 little data sets. And all of these 4 data sets have the same kind of statistics to them. So they have the same mean, the same standard deviation, the same odd, things like that. So when you look at data sets, very likely one of the first things you do is you look at their statistics, which is a very reasonable thing to do. But do the statistics tell you the whole story? And this is where the visualization comes in. Because once you look at these 4 data sets, being graphed, you can tell very quickly that there's something extremely different, fundamentally different about all of these data sets, right? For example, you can probably very easily identify that something here and here was off, right? Like there's a very extreme outlier over here. There's a very extreme outlier over here. What's going on? If you look at this, you can probably tell that this is probably not linear, right? And if you look at this first data set, which kind of looks more like what you would expect from normal data that you gathered, it's not exactly perfect match to the regression, but it kind of is in the same vicinity. So this is kind of what you expect when you see that the mean and the standard deviation are kind of, and there are there's some correlation with kind of those numbers. That would be what you expect. So this makes us realize that the visualization as a first step to kind of understanding the data is a very good idea, right? And if you're interested, some people have actually developed a much crazier set of examples for the same kind of trick, same statistics, different visual representation of the data. It's called the data source data set. So when we talk about visualization, we have these bunch of different things that we want to talk about. The first being that it really helps us with a lot of these tasks that we need to do, the data exploration, the analysis, but also at the end of the process of looking at the data, we also want to communicate it and present it to other people. So this is part of that use case. But also it helps us illustrate a bunch of different scientific data. For example, the geospatial data, we obviously makes more sense to visualize it rather than provide long positions in a big table. It helps us show comparisons, so we can show things side by side, or we can show things juxtaposed over each other, which makes it very easy to do these kind of comparisons. It helps us see a lot of data in a very small kind of space on paper, basically. And it just has a lot of these different kind of modalities, like the diagrams, the animations, the interactivity, things like that. So if you guys are the data scientists, right? And your goal is to do all of this science, and your science is supposed to serve this purpose of helping people make a decision. And this is the part that you find cool and interesting, right? You like to do the data analysis, but making the policy and taking action, that's the, maybe we can say, the good result of doing all this work, because people can actually benefit from it. Then the visualization is the connector between those two things. Okay, it's a way for you to explain to policymakers that are not necessarily scientists, or even people that understand your topic very well, with visualization. And to do that, you kind of need to know your audience. You need to choose good encoding. We'll talk about that in a second. And you need to use design principles, which we'll also talk about in a little bit. And together, these components will help us tell a story. Okay? Why telling a story? Because people remember stories. So here's an example of a good storytelling. This is a chart from 1861, drawn by Charles Joseph Menard. And it is a description of Napoleon's losses during the 1812 war. He was Washington. And there's a lot of stuff going on in this visualization. But what you get immediately is this kind of a visceral sensation of the army starting here with a large body of people, and over time, the army gets smaller and smaller and smaller and smaller and smaller and smaller and smaller. And there's really a dribble of the soldiers coming back home after everybody else either abandoned or died. Right? So this is a really good way of expressing, this great loss of soldiers during that war. And there's other aspects of this visualization. It shows, for example, the temperature in different locations, things like that. But the gut punch, the story is, look at the army in the beginning. Look how tiny it was when the story ended, right? But like we saw, just like we can look at these something like this and say this is really good storytelling. We also saw that there's a bunch of different ways that you can make visualizations that are very bad. And one of the things I mentioned was the 3D kind of spinning of graphics. Whenever you see something like this, everything that's closer to the front of the view is going to look bigger, and everything at the back is going to look smaller because of perspective. So it makes it hard for you to actually tell the information. This is the same kind of problem that we had with the women. Once you're saying, okay, I want to show only the interesting part. The interesting part is at the top, right, where you see the differences. But that skews our perception of the data, because now we think that there is visually almost twice as much in 2013 than in 2012. And that is not the case, right? Because we have the majority of the data is below the non-existent axis, right? Another example is when we kind of choose the part of the data that we want to showcase, and therefore we manipulate what is actually the result of that data. And in some cases, you probably have seen visualizations that have quite intentionally been designed to mislead people. This is an example where we see that the last point should actually be the lowest point, but it's drawn to be similar to the point before, right? And this one, can you guys tell what's wrong with it? Hmm? It's flipped, right? So it's trying to show you, look, when Florida enacted its standard ground law, the statistics went down. But actually the statistics went up, right? This is just flipped. This whole graph should be flipped on its head, right? So this is a way of specifically lying to the people that are trying to look at this visualization, unless they spend those extra 2 seconds to be like, wait a second, why is the 0 at the top, right? So this is going to be about how we want to create visualizations that are good. Okay, and when we talk about that in class, I always ask people to stand up and say, I pledge to always use my powers of visualizations to create good charts and not mislead people, things like that. And this is the general description of the process for creating data visualization. You usually start by getting some kind of data, which is what I assume the part that you guys are probably more familiar with. Could be a database, could be a simulation, could be a collection of sensors, and then you get the raw data from that, and then you kind of process it. And processing can take a lot of different shapes. It could be cleaning data points that are incorrect. It could be using some kind of transformation functions to get to some kind of a different variable and stuff like that. And that gives us this enriched data. And then we have to do this step called mapping, which helps us get the representation, and the rendering will get us the actual image. I'm not going to go into the rendering too much because we don't have that much time, but what is data mapping, which is also known as visual encoding? So visual encoding is the part where we actually choose the graphical elements that we are going to choose to represent our data. So remember that the chart before with the gumballs, someone made a choice to represent the ages of people in different countries in Europe with a circle. Was that a correct choice? None of us thought so, but that was the choice that was made. So we have these bunch of different types of visual encodings that we can choose from. And a lot of these are better or worse depending on the type of data that you're trying to map. So for example, if we have categorical data, then we're probably going to map them to something like hue or shape. If you have something that is more ordered or quantitative data, we have other possibilities like saturation, luminance, size of things, and other things. We're going to see more examples. So we have to choose the visual encoding based on the type of data that we're looking at. But also, we have to keep in mind that the different visual encodings have different levels. So levels are going to be the different, I guess, elements that you can differentiate between. So for example, if you look at different hues, at some point, let's say you have 8 different hues, you're probably going to be fine. Once you go into 12 hues, some of those hues are going to be too similar to each other. Okay? So that will be a bit trickier for you guys to create an effective visualization with. How to choose an encoding? There's a lot of different tools out there that try to help you. One of the famous kind of chart choosers is called the Abela chart chooser. And it starts with this, what would you like to show question? If you want to show distribution, a comparison, a relationship, or position, then it asks you how many variables you have and things like that. And it tries to suggest a chart. But there's obviously a lot of different charts in general, and this is just 2 more examples of kind of tools that will help you choose different visualization. And again, you can get these slides from the Sage one. But kind of like I was hinting, just because a data encoding is appropriate for a type of data doesn't mean that it's the best choice for that kind of data. And we can easily see this in this example with these 3 pie charts. So this is an example of 3 pie charts for votes for 5 candidates in 3 polling stations. And you can see that they're slightly different, but they're still kind of similar-ish. So if I asked you in which polling station A, B, or C did the yellow get the most votes? You're gonna be like, maybe? I don't know, right? It's kind of hard to tell the difference because pie charts are very tricky. It's hard for us to perceive angles, and when we're trying to show more than 2 or 3, it becomes very difficult for us. So there's nothing wrong with the existence of pie charts. You don't have to stop using them, but only when you have very, very few items to kind of show. This is the same example with the bar chart. Right? So when you look at the bar chart and they ask you, well, which one has the most red votes? I think you can very easily say that C has it, right? Because our perception of length is much better than our perception of angles. So this is kind of bringing us to this point that there's a lot of these ideas behind visual encoding, but they're all kind of based and related to human perception. And there's a lot of studies about human perception. I'm going to talk about it very briefly. But again, this is a ginormous subject. And the perception is also the reason that the bad visualizations were affecting us in the way that they were, right? So very, very oversimplified progress of processing visual information. We see through our eyes. Those are our sensors. We store it in iconic memory. The iconic memory is very, very brief. The iconic memory is going to send some information. There's a question in the chat. I'm sorry, am I? Okay. Just let me know if my audio falls out. Okay. So the iconic memory then transfers the parts that it finds most important to the visual working memory, which is also our short-term memory. And our short-term memory is trying to figure out what it is that we're looking at by kind of looking at all of our past experiences and the things that we know about in our long-term memory, right? And the reason that this is called the processing visual information is, and I want you kind of to realize this, the same process is happening in other channels. So this is our visual channel. We also have an auditory channel. We also have a haptic channel. These are happening parallel to each other. So as we're processing things in our iconic memory, we also have auditory memory. We also have haptic memory. Yeah. So this is kind of more of a description of that. The iconic memory again is very, very brief. It's going to be several, like it could be like 100 millisecond to store it, or up to 400 to 500 milliseconds. It's kind of like our buffer, and it helps us just maintaining this coherent picture of what is happening. And it helps us identify, shapes, edges. Here's an edge. I'm not going to walk right into it, right? Sometimes we don't look correctly, so we will go into our edges and bump our legs. But that is what it's trying to kind of help us perceive. And some of the attributes that we then are going to use as visual encoding are also known as pre-attentive attributes. And the thought historically was that those are attributes that we notice before we start paying attention to what we're looking at. Now, that's not actually what happens in our brain. We notice it. We always pay attention. But these are the things that are captured so quickly. They're captured within the stage of the iconic memory. Now, after the iconic memory, we're going to pass whatever information is most relevant to the visual working memory. And this is where you may have heard that we can only store so many things at a given time. So a lot of times people will say that you can store 5 ± 2 things in your head at the same time. So for example, if I were to say, okay, remember the following string of numbers: 75, 92, 100, 6, 17, 23, 105. Yeah, you're losing it, right? In the beginning, you can start paying attention, but as more and more data chunks are thrown at you, your grasping, and that's what well, it's not the visual, but it's it's auditory one, but your working memory is kind of losing the previous parts. There's ways around it. I'm not going to go into this. There's ways to chunk bits of information and stuff like that. But the general idea is we're only going to remember so many things at any given time in our working memory. And then we have this long-term memory that helps us associate things to comprehend what we're looking at. So here's an example. Oh, let's do the example, then we'll look at it. You know what? The implication for design is to take advantage of pre-attentive visual attributes, to try not to overload our visual working memory, and to associate things with other things in the world that the user might be familiar with. And this is the example that I'm going to show you guys. One of the pre-attentive attributes is color. So if you have something that is of a different color from everything else, it's going to stick out at you. Imagine that everything is red and one thing is green. You're going to see that green thing, right? So in this example, this is a visualization of the height of a wind turbine. The wind turbine is blue while everything else is black. So your eye kind of immediately goes to see that thing that is different from everything around it. And we were only trying to compare a handful of other structures. This is already probably too much for most people, but they're going to look like maybe to one side compared to this, and then the other side compared to this, right? Just to get the scale of what is taller, what is less tall than the wind turbine. And this visualization is also using structures that we know about in the real world, or at least some of them are probably known to us. And kind of uses that as a way of evoking that memory to give us a more visceral feel of the tones of this. Okay? So if you've ever actually seen the Statue of Liberty, you will have like a sense of size. So again, what were those pre-attentive visual attributes? We're going to see their distribution across form, movement, spatial positioning, and color. Form can be orientation, curvature, length, numerosity, marks, width, shapes, sizes, and groupings, right? So you can kind of tell when something is off. But it should draw your attention more than everything around it. Movement, flicker, velocity, direction. So this one you see is moving kind of up and down while everything else is moving sideways. So you should be paying more attention to it than everything else around. Right? In terms of spatial positioning, most of our graphs, for example, are scatter plots. They use 2D position, right? Things are along the x-axis, things are along the y-axis. So you can easily differentiate if something is extremely off to one side or extremely off in the other axis. Right? Stereoscopic depth, there's a lot to be said about 3D visualizations. I'm not going to go into it, but because we have two eyes and they're both seeing slightly different view of the world, which you can tell if you close one eye and then the other one. Yeah, like you can tell that there's like a slight overlap between the views of each eye, and that slight overlap helps us, and the way that our eyes are trying to focus on things really help us understand the depth of things in the world, but also in drawing. And there's the concavity and convexity of things, so you can kind of see that this image would have outwards protruding things, and this would have inwards protruding things. So these are all things that should be fairly fast for us to perceive. And then there's color. You saw that before in the other chart. Here just refers to the different colors. Saturation refers to how vivid that color is. So imagine that you have the full color at top, and then you add more and more slight amounts of gray to it. And then the value describes how light or dark color is. Now note that color is a very tricky type of retentive attributes. In a lot of things, it works great. But if you have a lot of different values, remember we talked about levels before, it could disturb your resolving power. Just like I said, if you have 12 different hues, are you going to be able to tell them all apart? Probably not. Likewise, if you have these gradients of saturations or something like that, are you going to be able to tell the different levels of saturation apart? Probably not, right? So what is the level of resolving that you can get between this kind of scale should really affect what you choose for your visualization. And there are studies that try to understand which visualizations are better for what. This is an example of a choroplast. This is a kind of map visualization. And I think historically, it was very common to have this kind of this kind of a rainbow effect on it. But when you look at something like a rainbow and your data is quantitative, right? It's actual numbers. You have to ask yourself, how do you map it? Like, why would green be more than blue and less than red? It's kind of arbitrary. Okay. Another point that I want to kind of drill into you guys is that graphic design is an important part of visualization design. Again, I talk about this in class. I know that people are not necessarily graphic designers and they're not necessarily artists or anything like this, but there's a lot of this fundamental understanding that helps be aware of what you need to be aware of, kind of thing. So hopefully, worked on you? Yes. Okay, this is called visual hierarchy. Visual hierarchy directs the order in which you read things on something graphical. So if you're trying to draw attention to one thing more than the other thing, you should make it more prominent, right? This is kind of what it's teaching us. So there's a lot of these little things to understand. There's this whole suite of Gestalt principles which help us group and associate items together. So things like things that are closer together appear to be grouped, things that are more similar appear to be grouped, things that are inside of an enclosure appear to be in a group. Once you put something with a line, you actually connect it with a line. It tells you that those things are strongly connected. So all of these things are relevant when you're creating a visualization and you have items and you want to show something about those items, right? Right? This group is different from this group of points. How do you manifest it? You could do like a background behind one and the other. It will make a very strong impression that they're very different. Fonts. And again, I will leave you to ponder for a second. Okay, pondering done. So font choices are important. Generally, we want to use things like censored fonts when we're doing on-screen text like this. This is on-screen, so I'm using a sans serif. The serif fonts like the Times or there's a bunch of different ones, Georgia, whatever, are the things that people usually have used for printed text. Monospace, like if you're showing code or something else like numericals that have to be perfectly aligned, the monospace makes sure that every character is exactly the same width as every other character. Stylish fonts, these for your wedding invitations. Probably don't want to use them in a visualization unless you have that graphic design chops and you know what you're doing. If you're trying to help people read faster, you probably don't want to have too many uppercase words. People read uppercase words like slower than things that have at the very least upper and lower cases because you're kind of looking at the shape of the word rather than just at the letters. But if you're looking at something that's nonsensical, like, I don't know, Comet UA1138, then you do want to keep it in uppercase because then it will kind of brand the shape of that nonsensical token in our brain and we'll easily recognize it in the future. When we're making these basic charts, bar charts, line charts, pie charts, scatter plots, things like that, we always want to make sure that we're choosing the correct or I guess the least bad visual encoding. You want to make sure that everything is labeled. You want to make sure that there is a meaningful title. Most people will look at the title before looking at anything else. So if there's no title, you're having people start with a disadvantage. They don't know what they're looking at. Okay. Make sure there's a legend explaining all of the different encodings, what are the lines, what are the points, what are the colors. Make sure that the labels are readable. So what does it mean to make sure that something is readable? You take your visualization, if it's a piece of paper or your screen, and you stand apart from it, right? Can you still read it? If you can't still read it, no one else will be able to read it either. Okay? Also put them close to the items they represent because Gestalt principles say that proximity helps us group things together. You want to avoid 3D in simple charts. There's other places where 3D is super useful, but not in bar charts, pie charts, and so forth. Background color of the chart. So a lot of times the chart is going to be either white or dark if you're using dark mode or whatever. But sometimes you choose different background colors, but you have to be really careful because the background color will affect how you perceive the colors, the other colors that you have on the chart. So if your chart is only using black, fine, you can probably use a lot of different colors. But if your chart, for example, is using blue, red, and green markers, and you start playing with that background color, the background color will change how people perceive the blue, red, and green. And this is again, I'm not going to go into it, but perception is a really big part of trying to understand things. Also, you also want to think about colorblind people. Again, remember that chart with the apps, the 3 greens, the 5 blues. My husband is colorblind. There's no way you could look at that chart. It's anything other than there's this green thing and then this blue thing. And some of those green probably will look blue thing. I don't know. And then you want to make sure that everything is clearly differentiated. Again, if you do that, look away, look from afar, test. Are you still seeing what you thought you were seeing when you were looking at it close? Right? And again, I know this is not what you were signed up for. You're data scientists. You want to do the hard work. You want to do the scientific discovery. But all of these things are gonna make it so other people will be able to share and enjoy your discoveries. So this is about getting to that point, the communication, right? Okay, so I want us to do another activity. It's going to begin on the stage board. And I want us to look at some simple charts. I think the ones that we're looking at is line graphs, bar graphs, and pie charts. And we're going to try to kind of, you guys are going to try, restyle those things. So try different colors, try different fonts, whatever comes to your mind based on all the stuff you just talked about. And there's a little space over here. Oh, sorry, over here. So I kind of started this off. There's a cell. So by the way, sage cells can be started from the kernels. If you want, you can create a kernel for yourself. Over here, if you want, you can use my kernel. You can create a sage cell. Once you create a kernel or use this, you can see that this is a sage cell that has some very, very short pieces of data, sample data. And then that is going to be in, the data is visible from all other sage cells on the same kernel. So if you want to use different data, you want to create your own kernel. But this is where you kind of choose. Yeah, Andrew already created his kernel. And then over here, there's an example that uses matplotlib to do these 3 graphs. You can see them here, right? So you should be able to drag an image out if I want to. And then this one uses Seaborn. Oh, no, this one uses Seaborn. No, this one uses Plotly. This one uses Seaborn. All right, so I can drag this out. And this uses Plotly again. We'll show you the trick in a second. I didn't write any of this code. Oh, this one will not let me drag the image because it's an interactive widget. And you can tell because I can hover over things and drag them around. So this is where I actually got yeah, these are the 2 matplotlib, and you can kind of tell that they're basically using the same kind of style, right? Whereas Plotly was using a completely different set of styling decisions. So I have this chat over here. You can start as many chats as you want. And if you start your queries with FS, you will be able to ask Sage questions. And that's how I generated my code. Okay. So I want to give you guys a few minutes to play around. Okay. Even if you're just enjoying seeing how the OpenAI generates code, stuff like that. But try to see if you can figure out things like, oh, how do I change the color of these bars? How do I change, the width or stuff like that? Just to play around and see if you understand the way to make these different decision choice. And I also had a bunch of questions here if you guys want to think about them, and we'll talk about it in like, I don't know, 10 minutes for good on time. Okay. You wanna run it? This is kind of like a Jupyter notebook. You have to run your cells after you create them.
On plotting libraries being solved.
Yeah, I don't think you need to pip anything. But if you do need to do something, you can actually pip from these cells. But these libraries, I believe, were all, yeah, you just imported them. Yeah, and you can have as multiple chat boxes. You guys can create them for me. It's a good chance to kind of see some of the Sage stuff that you probably don't use very often. Anyways, anyone online have a question or whatever, you guys can put it in the chat. This is a good point in time. You have to choose a kernel before you can type things. was a board meeting. Kind of at the advantage at this point where we can basically just ask the questions that we want to know and get code examples pretty much directly. This was the question. How do I color bars in different colors? This is the example in Seaboard, for example. With this colors array that is palette variable. Or in matplot, just call the color. So hopefully you guys kind of enjoyed playing with this, and you can continue playing with this. The couple of questions that I had. Now that we talk more about styling and things like that, if you had to restyle your charts, those were the defaults that you got, right? This blue bars for the bar chart, for example, and so forth. If you had to restyle for different types of data, how would that affect your choices about the style, right? So, for example, if the data was about political votes, how would you choose to style your actual visualization? Mhm. Thoughts?
Color the graphs, the square scheme color.
Yeah, but whatever it is if the thing that that is associated with your data has built-in color associations, it's a good thing to use them because you're using something that a person already has in their long-term memory, right? So if you're doing this political vote, whatever, you'll probably do the red-blue kind of comparison, right? Maybe gray for other whatever. So using colors can be very helpful. Let's say you had some sports and health stats. What potential thoughts would go into your mind when you're trying to style that visualization? So let's say you have a specific goal, right? You're counting your step and you have a specific goal in mind. You want to do 10,000 steps a day. Not 10 steps a day, that would be quite an achievement in the opposite way. But you have this goal that you're trying to achieve. So how can you visualize a goal and whether or not the data goes beyond that goal or under that? What's a way to show that? No? Hmm? No, I meant like in terms of like how it would actually look. Like one thing you could actually do is you can actually show what the line of the goal is, right? And then your data could be something like this, right? So you immediately get a sense of what is above and what is below. Another thing you could do is you could have bar charts that are maybe green that go above the line, right? And for the data that doesn't quite make it, you color it with a different color, right? So you immediately get a sense of the days where you did better than other days. Does that make sense as a kind of visualization cue that tells your story really, really quickly? Okay. So let's just quickly go and finish um, this. Beyond the basic charts, there's obviously a lot of other types of charts that I'm not going to even cover. These are just examples of some map-related visualizations. This is a 3D network. And obviously there's the more visually beautiful charts which were actually created by graphic designers and not necessarily data scientists, which are infographics. This is a sketch for the actual infographic at the end. In some cases, the visualization is basically the end product, which is in this case the simulation of some kind of a dynamic flow, right? So let's say you run the simulation, you actually need to see what's happening. This is the part where you're interested in the visualization, right? Other reasons that you may use visualization animation would be to show change in time. So this is the little example for that. It kind of shows you over time this is the shift in temperature. So you get that sense of being in the story while it's unfolding. You can see over time, we're going above the average. Well, not yet, we're in the 60s. But now we're in the 80s. So the animation is really kind of helping this visualization really tell a story, taking its time and going through it. And then it's actually showing us this 3D tube that it's creating, which is really kind of interesting. You can also use animation to switch focus between different facets of visualization. We can add storytelling features like an audio narrations. You will sometimes see the explanation, which is, again, it's all about communication. So actually telling the story by telling the story could be very helpful. Or it could help us kind of enforce a very linear way in which our participants or our viewers see our data. So instead of just looking at it all in one go and having them explore wherever they want, we want them to see this specific thing first and then this thing and then this thing, because that helps convey our findings. Animation can help us do that. There's 3D visualizations. Again, 3D for the basic charts was not necessarily a good thing, but there are a lot of actual uses for 3D visualizations that are good. Interaction. Once we go digital, we have this ability to enhance all of our visualization by adding these interactive techniques. We can make a visualization system that enables the user to get more context for the data. So imagine you have this higher view, and then you can kind of zoom in on specific elements within the data. We can filter and sort things. We can use clicking or hovering to get more details per point, because maybe we have some kind of a scatter plot, but it's only 2 dimensions out of a bunch of other dimensions, and we want to show more on demand. So every time you click on a point, you'll get the full data table behind it. Or we can use it again to activate information. So there's a lot of different things that we can do with interaction, and hopefully try to be more engaging with our users. And then, of course, there's immersive visualization, again, very active field of research. Things like VR, augmented reality. This is an example of a room we have in West Oahu where there's projectors on 3 of the walls and the floor. This is actually the next slide. So this is another way for us to augment visualization by having this physical model that we can then project data on top of. So people have both the data and the topographical context of how the data will look, on the actual island, as opposed to just as a 2D image, which most people don't necessarily comprehend. Okay, so I think that's because you wanted 10 minutes for this. Okay, so thank you guys for participating in the workshop, and I hope that you got something out of it, especially if you came in really kind of blind, no idea what is happening. I hope you get at least this set of criteria to think about. And when I do the visualization class, I always talk about, I'm not going to tell you how to create visualizations. I'm going to show you a bunch of different things to think about. You do the design, and you have to rationalize to yourself why things are why you do the choices that you make, right? And what would be the benefits. want to contact me, that's my email. And please do the participant survey for this workshop. Link and I hope the QR code is okay. It's what she sent me. So. And, is there any questions online or in the room? I don't know. Okay. So thank you guys. And I will leave this on for you guys to.
Yeah.